At this point you've done addition and subtraction, and you've done it the vertical way. So let's take a look at multiplication and division, and how you would solve one-step equations that involve both of those. So for the horizontal look at the multiplication property of equality and the division properties of equality, let's just write the number 10. Well, first of all, you know that 10 is equal to 10. And if I were to multiply the left side by 2 and represent this horizontally, I would still need that equal sign there. I could do the same, and would have to do the same, to keep it equal, and 2 times 10 would both be 20, and 20 does equal 20. So that's just sort of checking it out and seeing how you can double both sides, triple both sides, half both sides. As long as you multiply both the left and right by the same values, they will be equal. For the vertical look, and here's what I'm going for with the vertical look. I just want to show you what you'll end up doing when you do these problems. Here's 10, here's 10, but as we manipulate left and right sides of equations, it's really a lot nicer to either represent it this way, where we kind of just angle a times 2 up, or maybe show the entire thing in parentheses. And I know this says vertical look, but be a little flexible there. There's 10 times 2, becoming 20, and 20 does equal 20. By the way, I'm jumping down here just to use space. If I have to change each side of the equation, it's really not a good idea to multiply it lower. If you multiply it lower, it might imply to somebody else that you're talking about fractions or something. So avoid multiplying really low. Be sure to show it angled and up, because then it clearly is being doubled as opposed to halved. For the division property of equality, I guess we could use the number 10 again, but let's just do 20. As long as you take the left side and divide it by the same number on the right, you'll get 10 and 10. So that's the horizontal look of what the division property of equality looks like. By the way, 20 divided by 2 does not equal 2 divided by 20. The way we show numbers being divided is we put them afterwards. Okay, check out the division property of equality for the horizontal look. Well, the nice thing about the horizontal look is it's probably familiar with the way you've always written division, but it's also not going to be very helpful for solving equations. So for the vertical look, take 20, set it equal to 20, but this time we're going to represent division as a fraction. So here's divided by 2, here is divided by 2. And as long as I divide everything on the left by the same number as the right, we'll get the same answers in both. So let's look at these problems in action. The first problem says x divided by 3 equals 7. We're told to solve. We're told to check it. Let's do both. Now, if this were my textbook and I were writing problems down, you would definitely have to rewrite x over 3. And we'll get into that in problems 5 and 6, so let's not worry about that now. But with it rewritten for me, I see x divided by 3. And I'm going to solve these using multiplication, so that's sort of holding our hands through this. But I'm going to have to undo division by multiplying it by 3. So I write times 3. I show it at a slight upward angle. These 3's I want you to now cancel out on the left, because 3 over 3. And I changed my mind about that. Let's show just a little note. Like star this here and put 3 over 3 equals 1. As a little bit of a reminder to you. Well, 3 over 3 becomes 1. And so optionally, if you want to put a 1 times x, you may. But if that's clear to you, you can jump down and skip that step. So x is equal to 21. If you do write the 1, you'll have to rewrite x equals 21 just to further simplify it. But if you don't write the 1, and that makes sense to you, then just have x is 21 and box it. We were told to check the solution. We're going to do that. On the right side, where we have this area here, completely horizontal to the beginning of our work, like in the same line is what I mean, the value of x is getting plugged in to check it. So there's x, and now I have 21 going in where I see x, and x was divided by 3. If I can, I keep this in one line, and 21 over 3 equals 7 on the right side. And then once we simplify 21 over 3, well, 21 divided by 3 is 7. 7 does equal 7. And that confirms that our answer of 21 is correct. All right, in problem 2, we have 18 is equal to y over 2. So that I can write better, I'm going to pinch and zoom here. 18 equals y over 2. We are dividing by 2 in this step. So to undo division by 2, I'm going to multiply the right side and the left side by 2. Optionally, you can write 36 on the left is equal to y, and then cross out those 2's because they simplify, as I mentioned earlier, and become 1. Let me explain why I wanted to say optionally. In these single-step problems, you can jump to slinging this y to the left side because it's more common to say y equals something than it is to say 36 equals y. So here's y equals 36, and I'm boxing it. If that's confusing to you, then don't leave out this red step and include it so that you can track your problem and see that y came down but then moved once you were comfortable, as opposed to coming straight down and reversing sides. And yes, as we learn these, I still want you to check them all. 18 was the original equation, equals 36 over 2. And then 18 is just being rewritten on the left side. And 36 divided by 2 does give us 18. So I'm rewriting 18 in this step, but evaluating 36 over 2 on the right side to confirm that 18 does equal 18 and checking it. Make problems 3 and 4 OYO problems. So I'll write OYO for on your own. Check them. I'm going to put the answers up in just a moment for each of them. I'm going to count down from 5, 4. As long as this felt great, awesome. And do not turn your answer here into negative 1.2. Leave it as a decimal. Now over here, as you check it, if you wanted to change it to a decimal or whatever to avoid difficulty, I think I'm okay with that because you're kind of compromising and you're really just checking your answer. And I'm not going to talk at length about this fraction because it would make the video more about complicated fractions than it would be about solving these. But you're going to have a ton of different ways of looking at this. This is divided by 5 here. And then if I divide it by 3, then it's really this divided by 5 and then 3. So that can stay in the denominator. But I don't want to mess with anybody just yet. And this would be twice as big. So yeah, they are equal. And you could also put this in your calculator and then divide it by that. And your current calculators that you have simplify nicely that way. If you haven't done the second problem, pause the video and do it. You can pause this and look at what I did. The only thing I'm going to say is, just because there's a negative in here doesn't make the problem all that crazy. I think it's pretty straightforward. So in number 5, let's take a look at something a little bit strange. Okay, so let's say, we're solving these through multiplication. And let's say I have negative x equals 1. Well, this is not solved for x. In order to be solved for x, you have to only have x. So let's make a little note here in pencil. Let me see. I think you might have room up top. So let me rewrite this and make a note that says not solved. And hopefully that's clear to you that you can't have negative x equals 1. You have technically not solved for x, you have solved for negative x, and that's not going to help us. Well, the opposite of a negative is a positive, and I can always take some value like 5 and multiply it by negative 1 to make it its opposite. And similarly, if I had negative 5, I can multiply it by negative 1 to make it negative 5. I'm sorry about those 5s, those are poorly written. So take the left side, multiply it by negative 1. Take the right side, multiply it by negative 1. And this means that a negative times a negative becomes positive x. 1 times 1 becomes negative 1. And now it is solved. Now I'm going to erase this not solved note just so you can more clearly see the original problem as we go to check this. In purple, I see that negative, but I'm going to trace x over and make it green. So the first thing I see when I go to check this is a negative value. This negative value is not the same as the value of negative 1 that we found. To make that stand apart, I'll open up parentheses as I plug in for x and show negative 1. And then I'll finish rewriting the rest of the equation. Well, as you know, a negative and a negative cancel each other out, which means that the left side will be 1. And when I rewrite the right side, 1 does equal 1, and I'm good. Now let's do another OYO problem. And the reason I want to have another OYO problem here that wasn't written for us is just so you can see what the work ends up looking like. Because in your textbook, you'll have to rewrite the problem. So let's say that you saw that it was y over 5. Let's make it even more difficult. Let's put a negative there. And that was equal to negative 2. Now you see negatives in both spots, but that shouldn't mess us up. And I'm changing my mind about making this OU. I'll just talk through it. You can pause it and try it on your own if you'd like. Well, I'd have to multiply by 5 to get rid of the 5, but in the same step I should also multiply by a negative to address this guy over here. Multiply that by negative 5. The 5's cancel out. I won't bother writing the negatives cancel out. It's more markings than are helpful. Then we have a negative times a negative turning positive here, which I don't have to bother showing. I'll just write 10. When I go to plug it back in, negative 10 over 5 is hopefully going to be equal to negative 2. I simplify the left side, and I get negative 2 is negative 2, and I check it. Now the reason I wanted a couple blank ones here is so that you could see what happens when you rewrite it from a textbook or from a worksheet. And the thing that I'm pointing out is, as you start to cross things out, it becomes less clear what the original problem was because your markings overlap with the original problem. Let me back out from these. So we saw a handful of different problems where the fraction bars are shown, and we're always going to solve these this way. And we're still all going to check our answers. So in the next video, we're going to take a look at ones that are a little bit more challenging because there's more involved fractions.